All right, so what we discovered was that the math guys don't like large numbers under square roots. You know, as I always say, everybody hates fractions and square roots. We try to make them as small as possible. Okay, so that's what we've got going on here. So there's a couple different ways to think about this. And method one is what they call prime factorization. And what that means is you figure out all the numbers that you multiply together that cannot be factored into other things. So prime numbers, 2, 3, 5, things like that. Okay. Usually 2, 3, and 5 will get you where you need to go. Occasionally 7, but most of the time you're okay with these. All right. So here's how this works. What we want to do is we want to turn 108 into a whole bunch of small numbers multiplied together that will give us 108. Okay. And once we do that, then we're going to talk about how we turn this square root of 108 into 6 square root of 3. All right. So this is one method. Then we'll talk about another method after that. Okay. So first things first, like I said, maybe we'll get our calculator out for this. Tech guy did all kinds of stuff to this, so I'm not sure where some things are at. There we go. All right, let's put our calculator in. Try to make it a little smaller. So we'll go up with him a little bit. And let's move it over. That should do it. Okay. So what we want to do here is we'll start off with 108. First thing you always look at if you're going to use this method is, do I have an even number? In this case, the answer is yes. So that means I can divide by 2. And I get 54. So 108 can turn into 2 times 54. Okay. Now we look at 54 and we say, well, is that also an even number? And again, the answer is yes. So we can divide again by 2. So calculators come in real handy for this stuff. Okay. So we go ahead and do that. And then we find that you have 2 times 27. All right, so 27 is not an even number, right? So let's pop up to 3. Let's try to divide by 3. Most of us probably know that this is going to work. So 27 divided by 3 is 9. So then we go 3 times 9. And we know that 9 is 3 times 3. Okay. So you guys may have seen this stuff before. So what we need, we have to multiply 2 times 2 times 3 times 3 times 3 again to get 108. Okay. So that means this equals this. Square root of 2 times 2 times 3 times 3 times 3. Okay. So if we go that route, what this is telling us is 2 times 2 is a perfect square, right? That's 4. 3 times 3 is a perfect square, that's 9. Square root of 4 is just 2. So the way people tend to think about these when you're doing this kind of stuff. Why 3 threes? Because 3 times 3 times 3 is 27. So remember how we were breaking this down? We multiplied by 2. 108 divided by 2 is 54. Still an even number. We divided by 2 again. 54 divided by 2 is 27. 27 is an odd number. We can't divide by 2 anymore. So we had to move on to 3. Okay? So we divided 27 by 3, we got 9. And we can divide 9 by 3, and we get 3 times 3. That's why there's 3 threes. So what we're saying is, and we can do this, check it out. We can multiply these guys all together and make sure we get 108 back. So let's clear it out. So we go 2 times 2 times 3 times 3 times 3 equals 108. Ta-da! Okay, so then what we can do from here is we look at this thing and we say, all right, if I have pairs, I can move them to the outside as one thing. So if I have 2 2s on the inside, I can move it to the outside as 1 2. Okay? Same thing here. I have 2 3s, so I can move him out front as 1 3. Now I have the single 3 by itself. He stays in the house. You can only take him out of the house if you've got pairs. And then our last step is you just got 2 times 3, that's 6, square root of 3. Okay. The reason this works also, another way you can think about this, is we've got 2 2s. Well, you know, the math guys are lazy, right? So they say, okay, I've got 2 to the second power. Then I've got 3 to the second power. And I've got 3 to the first power. Now, they don't put it out here, but the index number on a square root is 2. So as long as 2 goes into 2, which it does here, 2 goes into 2, then you bring a 2 out front. 2 goes into 2, you bring a 3 out front. 2 does not go into 1, so this guy stays in there. And then the same thing's going to happen. Okay? So that's one way to think about it. The other way to think about it is you look at it and you say, well, can I pull some perfect squares out of here? All right, so let's try that. So we're just going to do the same problem, except we're going to do a different version of it. Okay. So pull a new slide here. So this time, once again, we've got the square root of 108. Okay. So we think about our perfect squares. 1 times 1 is 1. That doesn't help. Doesn't do anything, right? So let's list some of our perfect squares. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49, and so on. Okay, that's probably more than enough for what we need here. Okay, so the first thing we look at is we say, okay, does 4 go into 108? Here's a nifty little trick if you want to know if something can be divided by 4. You look at the last 2 digits. 0, 8. So 8. Can we divide 8 by 4? Very simple, yes or no. Yeah. So here's the thing. It doesn't matter how many digits. This could have like 12 digits in front of it. But if the last 2 digits can be divided by 4, the whole thing can be divided by 4. So in this case, we say, yes, we can divide by 4. All right, so let's do that. So we say 108 divided by 4 gives me 27. Okay. So then we could write it as this. So this equals the square root of 4 times the square root of 27. Okay? Now, the square root of 4 is just 2. So now this is 2 times the square root of 27. That's still a pretty big number. So since this guy is not an even number, we're not going to try 4 again. We're going to try 9. Okay? And most of us know that 9 times 3 is 27, right? So this would be 2 times the square root of 9 times the square root of 3. And again, the reason we do that is the square root of 9 is just 3. So I have 2 times 3 times the square root of 3. Put these two guys together, there's our 6 square root of 3 again. Okay? Now, what you can do a lot of times is when you get something kind of big like this, notice that we could divide by 4, we could also divide by 9. And as it turns out, 4 times 9, these two guys here, is 36. So sometimes you can do it in less, it took us 2 steps there. Sometimes you can do it in 1 step if you recognize that one of the bigger square roots will go in there. So you can always try these guys. So we knew that 25 wasn't going to work, right? And we can try 16 real quick. So we do 108 divided by 16. Nope, no good, right? So then we do 108 divided by 46. Bingo. All right. So if you realize that, then you could have done this by saying the square root of 108 is equal to the square root of 36 times the square root of 3, because you just multiply the two numbers together. 36 times 3 gives you 108. And then once again, the square root of 36 we know is just 6, and then the square root of 3. Don't feel bad. My Wi-Fi wasn't working either. I didn't get in here to what, like 7:30, guys? Something like that. I had to let everybody know on my phone that it wasn't working, so don't feel bad. Mine was even worse. I'm hardwired into the system here, and it still didn't work. So yeah, it's just been a major pain. It started actually yesterday afternoon. I had to end up canceling my Algebra 2 class because I couldn't get in. But I'm glad you guys all hung around here. At least we got to talk for a little bit here. Okay, so that's this basic story of these things. Is you're trying to make the stuff under the square root as small as possible. And you have a couple different ways to look at this. I don't know what your preference is. Okay, so again, here's another set of numbers. I want to know, well, can we compare these guys? And are they the same? So again, you can just look at it and plug them in and see if they work. Okay. So in this case, this says 1/2 times the square root of 120. So again, we can just go totally calculator in this. So remember, 1/2 is 0.5. If you're not sure what a fraction is as a decimal, remember, fractions are division problems. So 1/2, I mean, we know this one, but you can say, well, that's 1 divided by 2. That's 0.5. And take that times 120, square rooted, weirdness. So we get 5.477, blah, blah, blah. Okay. So now the question is, does the square root of 30 equal the same thing? So if we do 30 square rooted, it does. So this guy, these are both the same. Okay. We'll come back to that here in a little bit. All right, so this guy, square root of 68. So we go 68, square root it, 8.24, blah, 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 right? And then we do the same thing with the other guy. What's the other guy here? I forget what it was. 2 times the square root of 18. Okay. So then this one, you say 18 square rooted. And then times 2. That one's 8.48. The other one's 8.24. So these guys are not the same. This is a good way to check them. All right, next guy, square root of 96 and 3 square root of 15. I don't think these are the same, but we're going to find out. All right, so 96 square rooted. So 9.79, blah, blah, blah. And then the other guy was, what was it again? I forget. 3 square root of 15. Yeah, I really don't think this is going to work, but we'll try. So this one, you say 15 square rooted. And then take that times 3. And he's 11.61, so no, these guys aren't even close. Okay. So how does this one and this one happen to equal the same thing? All right, let's check it out. So let's work with just the square root of 120 to start with. Okay. So let's try the method where we use perfect squares. Our first perfect square is 4. Okay, so being this is an even number, there's a pretty good chance 4 is going to work, but we still want to check it out. So go to our calculator and we say, okay, we got 120, and I divide that by 4, and that gives me 30. I think we're onto something. So then this part would be rewritten as the square root of 4 times the square root of 30. And then we got this 1/2 out front. Okay, so again, the reason we pull out these perfect squares is because then it's not under the square root anymore, because the square root of 4 is just 2. So 2 times 1/2, these will cancel out. That just gives me 1, and then I have the square root of 30. So that's why these two guys work. Okay? Questions so far? Okay. So like I said, we're going to do a lot of practice, and the more you practice these guys, the better this stuff gets. Okay, so we're going to do that. Before I forget, let me put in attendance for you guys real quick so then we can take off here in a couple minutes. 1 minute, please. And done. Okay. So let's go ahead and check out a couple more and we'll call it a day. All right, so write each expression so that the radicand, that's the stuff under the square root, by the way, that's their fancy term for it, has no perfect squares other than 1. Okay, so again, let's look at this thing. We say, all right, 210, can we divide that by 4? Well, remember what I said. You take the last 2 digits, right? So that's 10. If we take 10 and divide it by 4, it doesn't go in there evenly. So 4 doesn't work. So our next try is 9. Not real hopeful on 9 either, but let's see what happens. All right, so let's do 210. Oops. 210 divided by 9. Nope, doesn't work. Okay, so clear it out. So then our next possibility, yeah, you could divide by 2. I mean, we could go that route if you want. We could go the route where we take and figure out all the numbers. Yeah, we could divide by 10 as well. The problem is we're looking for perfect squares that go in there. And 2's not a perfect square and 10's not a perfect square. But they do divide by that. Yeah, you're right. Okay. So what's our next perfect square? 4 times 4, that's 16. Chances are if 4 doesn't work, 16 probably doesn't work either, because that's 4 times 4. But we'll just make sure. So divided by 16. Nope. All right, what's our next guy? 5 times 5 is 25. I know that doesn't work, but we'll just prove it. 10 divided by 25. Nope. Does anything work for this one? Maybe not. All right, so next is 36. Well, 4 doesn't work and 9 doesn't work. 36 doesn't work. 49 doesn't work. 64 is probably too big. I don't think anything works on this one. It happens. That's a pretty big number to be square rooted. But let's try what Chloe said. Let's go ahead and figure out some factors, right? So she said, okay, let's do 2, right? So we can do that. So we'll go 210 divided by 2 is 105. Okay. So this one ends in a 5. Let's divide by 5, right? So if we divide by 5, go back here, 105 divided by 5 is 21. Okay, and 21 we can divide by 3 times 7. These are all prime numbers. 2, 3, 5, and 7 are all prime numbers. But notice none of these guys repeat. So we can't do anything. This guy doesn't change. He's still the square root of 210. So that's a pretty rare event to have one that big that nothing will come out of it. But it does happen. Okay? But like I said, Chloe, you said you knew 2 went in there. You're right. And 10 goes in there because 2 times 5 is 10. That's right. So we kind of went through the whole thing. And if you did what you said, if you'd done 10 times 21, then we know 10 is 5 times 2 and 21 is 3 times 7. But none of these guys match up. Okay? All right. Well, I want to thank you for making it through this difficult time here this morning. But we're pretty well out of time. So we will pick this up tomorrow. Hopefully everything works a little better then. All right. So I'll shut down the recording and hopefully we'll have a better time tomorrow. See ya.